Great. Good morning, everybody. A little bit of a promo to sort of get things going, if you will, just sort of exciting things. This is all about space this morning. It is a significant honor to be here. This morning, we are discussing and presenting Astrobee's return to flight, in all honesty. It's exciting to be here. I'm one of your hosts. The other two hosts are here, Jonathan Barlow and Yashvi Deliwala. We are Arkisys and been provided the sustainer and maintainer approval from NASA to go through this. This is a Zoom webinar. It's going to be recorded. So the Q&A will be enabled, so we'll be able to go through that once we're through the presentation. If you don't mind, if you guys come in, mute the mics upon entry as you're coming in. I'll do a quick intro this morning. As I talked about, it's both in person and on Zoom. We are going to record it. For those in the room, if you guys don't mind, silence the phones, just make sure that we can get through this. And there will be time for questions at the end. A quick layout of the schedule about how we're going to attempt to get through this morning. We have about an hour and a half. We have a lot of content. We want to give a lot of content, but we also need and want to get feedback from everybody. We will do some introductions this morning. We'll tell you who the heck is this company, Arkisys, which there may be some questions on that. We'll also reintroduce you to the star of the show, which is Astrobee. And then we're going to have some user testimonials from folks that have actually used this platform before. They'll be actually zooming in, if you will, and they'll be actually giving presentations. And then we'll walk through some use cases and some innovative ideas just to sort of seed the prospect of how you might be able to use this going forward. And then we'll go through the onboarding process and a quick status and a schedule for next steps about how we go forward. So that will hopefully take up the whole meeting. A plug for a tour, which will be occurring here at the same location at ISI tomorrow from 10:30 to 12. And we will also have the Astrobee device downstairs on the air-bearing table. First and foremost, a huge shout out and thanks to the host, USC and ISI, for supporting us here to actually present this. We really appreciate this opportunity to be the unveiling here at USC. As you might imagine, due to the, let's see, did want to, yes, the one thing that I wanted to get across. I am and have always been and shall always be a fan of science fiction, always. And as it turns out, this image, this activity that occurred in 1977, when I was just a little bit younger, spurned the imagination and innovation across the globe, but most importantly to another namesake of mine that I was lucky enough to have known. Dr. David Miller took this image and the concept of Luke Skywalker battling against some device that was flying around, and he gave it to his capstone design class at MIT, who then created what became known as Spheres. Spheres was the first free-flying robotic platform inside the ISS prior to the advent of what became Astrobee. So from my standpoint, it's a huge shout out to the Obi-Wan of the Astrobee community, Bill Miller, who got this all started. It's unfortunate, however, we are in a government shutdown, so the NASA introduction that was going to come is not going to be able to make it. Suffice to say, one of the things that I want to get across, most especially related to this opportunity that we have, is that we are stewards and careholders of some of the most innovative individuals that have invested in this unique platform. It is an incredible honor and a privilege for us to have been selected to take this forward. And it is only because, honestly, a huge number of people at NASA put in a lot of time and an effort and innovative ideas to make this happen. So from my standpoint, it's It's a huge thanks, and I also recognize we are stepping into some really big shoes to be able to take this to go forward. So my incredible hats off and thanks to NASA for offering this opportunity for us. Okay, so who are we and why are we here? So the bottom line is our company and the individuals in it has a vision to, in essence, create a commercial market in space. And we're going to do that via scalable space logistics platforms to develop an entire marketplace. Now, you might think, isn't the marketplace exist today? Well, it does, but it's mainly on the ground. We are literally talking about transitioning that marketplace and a lot of vibrant activity to in space. So that's what Arkisys sort of vision is for. The interesting thing is, in order to create a marketplace, you really need a strong pipeline. From birth to death, if you will, supply chain to use case. In this case for space, you have to go from launch to use. We have thought about this and we have addressed every one of the interstitial dependencies and connections to be able to make that happen, or at least to think through it so that we can work with other partners to make that real. So really we see a holistic picture about how to make this happen, and that's where we started from. When we're developing any platforms, we specifically have looked at that, and we look at platforms not just from ground to orbit, but anything to go from beyond as well. We have two sort of domains. The first is on the ground, software platforms, and then in space, we're literally building platforms that are able to aggregate and connect together. The whole point is to make it easier to reduce the burden, to get to space, to operate, and then to literally do business. That's our goal. The other thing that's critical, no question about it, is we cannot live in a vacuum. Marketplace thrives through partners and customers. So we actually, one of the first things we did is develop a 1G test bed. It's down in our facility in Los Alamitos, and we brought in as many different companies as possible to sort of demonstrate and work with them about what does this mean? What does it look like? So very proud to have worked with many of the companies here in Los Angeles area, as well as across the country and even the globe. Now, what's interesting is that this has not been done in a vacuum. And the cool thing is that we've actually demonstrated what would it look like end to end to bring something up to an orbital platform, take off payloads or cargo, and then do something with it on a stable facility that's in orbit. We did a demonstration very early on for the Space Force, and showed that if you have the right parts and the right pieces that are on board a platform through autonomous robotics, you can literally build a spacecraft, a 3-axis stabilized spacecraft, in 1 hour. Now, that's a typical sort of push by a founder that says we can do all these great things. But take that number. What if it was 10 hours or 100 hours or even 1,000 hours? If you could do this in space, that changes the game. And so that's what we've essentially demonstrated, and have done this in our 1G facility. And the goal is eventually to go forward. Okay, so who are the bodies that you can sort of throw shoes at or come talk to us specifically about? I'm joined this morning by Jonathan Barlow, who's going to take over as the Astrobee program manager. Next to him is Yashvi Deliwala, who is our mission manager. They are going to be speaking this morning, our co-host. Thanks very much, guys. Appreciate it. In the back, you'll actually see Noah Gladden and Sam Feldman, who are also supporting, both in terms of the onboarding process for the technologies that are going to Astrobee, as well as how to deal with some of the software and the flights that go inside. A recognition that we are also teaming. At this point, I can actually state that we're in the process of developing a memorandum of understanding to work with USC. And so two individuals that are critical to that, Pearson Lantala, who's in the back, who's actually been supporting a lot of the facility work here and transitioning, as well as Dr. Keenan Albee, who's got a lot of experience in actually working with Spheres and Astrobee, and we're lucky enough that he is in the LA area at USC that we can participate with. Supporting in terms of advisors or experts, I've mentioned Dr. David Miller, who's unable to be here today, but he's in the LA area. Dr. Raul Regani, who's with Arkisys, is going to be supporting. And then individuals we're going to have, which I see as sort of critical for our success moving forward, individuals from Johnson Space Center as well as NASA Ames that are moving forward as we've had it. There's a list of other NASA individuals that I would actually love to identify that were part of the Astrobee team who have offered, hey, if you need something, please reach out, which is outstanding and amazing. Jose Benavides is one of the biggest ones, who was leading a lot of the programmatic efforts with Jonathan up at NASA Ames. Again, government shutdown, trying to be respectful relative to their participation. Just to give you an idea, we do have some experience. I've been lucky enough, as well as Dr. Alba, that we've had experience with spheres before it was transitioned. Dr. Alba actually ran an entire Astrobee experiment, specifically the Rome, here at USC. They've had a really interesting experiment relative to clingers. And then we've worked with partners who also set things up into the ISS. Specifically, this was Cal Morris on the REACH project. So we've sort of collectively, we have a reasonable amount of experience to be able to at least say that we understand what Astrobee is, to be able to step in and begin to operate it as we go forward. Okay, so what do we do? What is a maintainer and a sustainer? The bottom line is that we don't own Astrobee. It is being loaned to us, and all of the support requirements that allow Astrobee to operate within the International Space Station ecosystem are being supported by NASA. So that's all great. Our job is to maintain all the equipment and hardware, so we don't want to drop the Astrobee as an example that's sitting here. And then really the bottom line is that our job is to make you successful, which means we are responsible to support all the users and the PIs through the entire process, to developing your experiment all the way through getting your data that eventually comes out. The cool thing is that there's going to be a lot of folks that have to work together for this. The bottom line is the International Space Station National Laboratory is the one that adjudicates all of this. We essentially report through them to them, and then support through the NASA centers to make sure that what we're doing or what you're doing and we're supporting you to do follows all NASA guidelines and programs. Yashvi is going to talk a little bit about what that means sort of in practicality a little bit later. In the big picture, how does Astrobee fit within our sort of business and commercial timeline? The interesting thing is that Astrobee is truly a mini microcosm of what we had already been pushing and planning for relative to the company. The idea that payloads can be sent up to be tested in a platform, that's what Astrobee does. It's able to provide data back down to the customers or to the PIs or the experimenters. That's going to be done, it's already done. That entire process is what Arkisys was laid out to start the process, except instead of being inside a shirt sleeve environment, Arkisys' plans was for it to be outside in the space environment. The cool thing is that Astrobee represents that first step, which now you can do reasonably low cost and very quickly, and you can get a lot more feedback relative to what's happened very quickly, and it's inside the ISS, which, come on, that's really, really cool. So the other thing I can let everybody know is that we do have a plan, because Southern California is such a rich environment for space, in all honesty. It's one of the more unique ecosystems, and we have really reached out to the companies that are here, the other government agencies, and most especially the other universities within this region to sort of provide an anchor for us. The cool thing is that LAX being international, we have a gateway through the rest of the country as well as across the world. And Astrobee had already been doing connections and doing tests with the international bodies and international folks that were out there. So again, our job is truly to be a nexus to flow as many folks from the United States into and through Astrobee, as well as reach out to international partners to be able to expand sort of the global reach relative to what we're doing. I can also say that we are working very hard with the city of LA, the city of Long Beach, and California and several universities to create a SoCal or Southern California Space Research Park. And the hope is that Astrobee would be an anchor associated with the kinds of really cool testing that we could do associated with Yeah, bottom line, we are super psyched and happy. Our business model had services. We did not build the platforms. Instead, we truly are almost like an AWS-like hardware software, but instead in space. So we had a menu of services already. Astrobee now becomes another piece of the services that anybody can get into space ecosystem through Arkisys. Okay, with that, I'm going to take a step back and allow Jonathan to actually introduce Astrobee.
So some of you I know are familiar with Astrobee. I know some of you are already familiar with Astrobee, but maybe some of you haven't. So I'm going to kind of give an overview of what Astrobee is. It is a robot. It was built to fly inside the International Space Station. It uses air for propulsion. And there's basically three main parts. There's the thing that flies around. Everyone think of as Astrobee. That's the model that we have here. There is a docking station, which is on ISS. So Astrobee can plug in and charge and get data over that in a good way. And then we also have ground station components for command and control and getting that data down. It's got a lot of features. I'm not going to go over the slide. Hopefully you guys can get access to the recording. I assume it'll be available to the registered participants, right? Yep. Just a couple things to highlight that were built in kind of user interface pieces. The touch screen, which has the eyes for display, it is an active touch screen. This is a smartphone type screen. It's got a number of cameras, some laser pointer, flashlights, some signal lights, and we have I would say, I call it a stock perching arm. It's a 3-degree of freedom arm, so it's not super fancy, but we have actually had some experiments, speaking of which, that have done some swapping out of that. So this is the same perching arm. It's actually pretty hard to see, but the finger is pointing to a new gripper that was launched by Stanford, I think, for doing gecko testing in space. So this is kind of an overview of all of the bits and pieces of Astrobee, as well as some of the other payloads and things that have been attached, that have been flown. One of the nice things that we were doing as a NASA community was to kind of foster the cooperation and reuse of hardware and some of that. And we're hoping to work that out with those hardware owners, because the people still own that hardware, but oftentimes have been willing to share that in the past. So we're hoping to foster those collaborations as well. This is an overview of kind of the different places that we test with Astrobee. So this is the NASA Ames Research Center table. There's a USC table, and then the big flat floor that's being developed as part of Arkisys. There will also be a part of that will be dedicated to Astrobee. So we'll have different ground testing capabilities for bringing your hardware, interfacing with the Astrobee and testing it in a relevant environment. And then, of course, the eventual goal would be to test on ISS in space. And that really is, in my opinion, a very useful test bed. You really can't simulate microgravity very well on the Earth. And then this slide is a lot of text, but it's just to show all of the different things that we have done with Astrobee, kind of give you kind of whet your appetite and give you some inspiration for the kinds of things that we can do, software things, hardware things. A lot of bits and pieces of Astrobee can be replaced with other bits and pieces if that's part of your interest or experiment. So just to say that Astrobee is kind of a good test bed for testing things in space. Cool. I think that's it for me.
Thanks very much. Yeah. So at this point, I'm going to stop sharing. I'm going to transition the sharing over to Yashvi, who is going to help lead us through the presentations by the users, the past users that are here. So let's see, the first one up is Alyssa, I think. Alyssa, are you on? Can we Can we
Yeah.
hear you? Awesome.
Melissa?
Hi, Jonathan. So good to see you.
Okay, you're up.
All right, cool. Hi, everyone. My name is Alyssa. I'm representing MIT today in the Space Enabled Lab, and I'm here to talk about zero robotics. So Zero Robotics is an annual ISS programming challenge for kids interested in STEM. So Zero stands for zero cost. We provide this program with no entry fees for any student teams that are wanting to join. Zero is also for zero configuration. Everything that we do at ZR is programmed online. Um, and of course, zero is for zero gravity. Students get to run their actual code on ISS. And also, zero is for zero experience. We really offer this program for kids from the ground up. So, new coders, anyone who's interested, doesn't need any background in coding. They could just join the program and we'll teach them with block-based coding, and on our user interface online. Next slide. All right. So we really engage kids with these space-themed coding challenges. So these are the last 4 years that we were running on Astrobee. We've had a simulation-based challenge where they complete tasks in this space environment. So each yearly challenge really involves a space-related theme. So we've done satellite docking, space debris management, resource management, and most recently, our last year's game was called Galactic Greenhouse, and that was a kind of plant management type of game, similar to like Stardew Valley. Um, we've also make these like concepts, which are often difficult for students to understand, really accessible. So we provide a kind of gamified setting for students to really understand these core coding challenges and coding concepts. Next slide. In a brief history of zero robotics, we've been working with spheres. We were using ZR since the spheres era. So, starting in 2010, during the ZR Summer of Innovation, we hosted a small pilot program with 10 teams, and we kind of expanded on. So, throughout the years, we have worked with thousands and thousands of students, and really offering a depth of knowledge. So the program runs for 6 weeks every summer for middle school, and then we've also hosted in the past a high school program that runs in the winter, that we've recently just restarted. Next slide. Yeah, and just briefly about our high school program, we relaunched in the winter of 2024. And we piloted it with 10 Massachusetts-based teams. And that was really successful in transferring the knowledge that we have with Astrobee working with middle school and forwards into high school. And some previous milestones that we've had with Astrobee when it was still under NASA, we were working with multi-robot data sharing. So we were configuring a DDS bridge so that we could utilize two robots on ISS to kind of complete these games and developing these custom ROS topics for robot communication. We're also introducing crew interaction behavior so that students have kind of more availability to interact with the astronaut through their code. So we have hand gesture recognitions, which was new to Astrobee, and also abilities to kind of reorient Astrobee to capture crew photos. Next slide. But yeah, just keeping it brief, this is our team. We're led by Professor Danielle Wood, who's jointly hosted in MIT Media Lab and MIT Aero Astro. I'm the PhD student lead. And then we also have Denuri, Dr. Scott Dorrington, Katie McGrain, who is super amazing and is part of the Innovation Learning Center, who really hosts a lot of our educational outreach. And then also Mizan, who is our website and IDE specialist. But yeah, thank you so much. I'm so excited to be working with Arkisys.
Thanks very much, Alyssa. It's really a pleasure to have you. Really, really appreciate it. Next is, I think, Kirk Hubble, who's going to talk about Astrobee from Abruda, a company up in Canada. Kirk.
Hello, everyone. Thanks for taking the time to hear me talk about my use of Astrobee. So Obruda is a startup company from Canada. I'm a co-founder and the CTO. And we've been using the Astrobee facility for the past 3 years on the ISS. And we just wrapped up a testing campaign in May of this year. So Obruda, we build autonomous spacecraft docking software for the in-orbit economy. We essentially make it really easy for spacecraft to dock with each other autonomously in space. And if you go to the next slide, the reason we do this is to make on-orbit logistics, life extension, inspection, refueling, deorbiting space debris, relocating other objects in space. All of these different industries, there's a lot of companies coming online in recent years, and we're trying to make their lives easier by essentially providing the docking portion to these different folks. So on the next slide, I have a video that just sort of explains what Obruda is and shows our testing on the ISS. And there should be some audio. If you don't hear the audio, let me know, and I'll talk over it.
Talk over it if you don't mind, Kirk.
Yeah, sure thing. So so here are just some examples of things that we can do in space. So here's inspection maneuvers, all sorts of things where you have one spacecraft getting close to another. This is even cargo delivery. Say you launch an extra piece of cargo and needs to be captured before delivering it to some sort of station. Even some futuristic things of docking to mega stations in space. All these use cases require one spacecraft to be able to approach safely and dock with another spacecraft. And so Astrobee is a great platform to do this sort of testing on in space. So Obruda did 5 experiments over 2024 and 2025. Astrobee has cameras on board, which is great because we can use one Astrobee to take pictures of the other Astrobee and try to see it, hence AstroSee, and try and figure out where the other Astrobee is. So you can see here there's this sort of green overlay on top of the other Astrobee. That's our computer vision algorithms at work. And so you can see the green overlay sort of right on top of the other Astrobee, and that just means we're happy with how our algorithms are working. And here's really a full end-to-end test that we got to do in May of this year, where one Astrobee, the yellow one, is flying through the gem on the International Space Station towards the other Astrobee Bumble. And you can see our computer vision results on the right-hand side, and then on the left as Astrobee's coming in. Now, we don't have any docking ports on Astrobee, but we did just do a sort of a controlled bump to simulate the 2 Astrobees docking. Other folks have had docking ports, which is great. But yeah, that'll be future work for us to get integrated with some actual docking technology. So one thing that also is great about Astrobee is we had to run our computer vision algorithms on board, which was difficult, and we needed a GPU. So Astrobee natively doesn't have a GPU built in, but thanks to the expansion ports on the top and bottom of Astrobee, we collaborated with another user who did fly a computer with a GPU in it. So it's kind of hard to see, but on the top of Astrobee there's an extra unit that's installed, and that has a powerful GPU, which we were able to run our computer vision algorithms on, which is great. And so far, the Astrobee users have been extremely collaborative and wonderful to work with, and I'm sure Arkisys is going to continue that trend going forwards. Next slide. yeah, so that's all from Abruda. Yeah, looking forward to seeing the future of Astrobee, sorry, with Arkisys. Thanks, everyone.
Thanks very much, Mark. Really appreciate it. Thanks. Next one, we should have Cal Morris, and I think Austin is going to be walking us through his amazing activity with Reach.
Yeah, appreciate it. I'm excited to be joining, and I'll call out that some of these I'll be running through the slides pretty quick to get to the more exciting stuff like what Kirk was just showing of videos and images from Astrobee. But yeah, so I'm Austin Morris, one of the co-founders of KMI. I serve as the CTO, and we can go to the next slide. And we are basically a in-space servicing organization based in northern Michigan, focused on relocation of assets in orbit. We've got a whole phenomenal team behind us. Every individual who had some amount of hands-on with building our payload for Astrobee. And in the middle there, you can actually see Sonny Williams, who you'll see on the next couple of slides as well, who was actually up on station operating our Reach hardware on the Astrobee, and then came to visit us after getting back to terra firma. We can go to the next slide. So as mentioned, the problem we're solving overall is how do we grab assets in orbit and relocate them? And that's both for life extension and for removal of objects that are in the way, debris, as well as dead assets that may be occupying a spot that new assets want to be placed into. And all of that relies on us developing a technology that's capable of doing that, as well as testing and demonstrating that capability. So our focus was really how can we demonstrate the capture system that we've developed in microgravity without necessarily investing the full amount of money to and time to build and launch a full spacecraft to do it. We wanted a stepping stone along the way, and ISS and specifically Astrobee provided the perfect opportunity for that. Next slide, I think should be some of the images, not yet. So some of the images of the overall mission. This basically walks through how we're going to approach that mission overall. I'm going to mostly skip this slide in the interest of time, but wanted to make sure it was included for sake of recording after the fact, but happy to dive in further in future on the overall mission. Moving to the next one to focus specifically in on Reach, this is what that demo looked like on station. So here we had a cube serving as our capture object, used in this video MLI stand-in faceplates. We also had a number of different other material faceplates that could be swapped out to essentially give us a wide variety of capture targets to simulate. And then you can see behind there, Bumble, the blue Astrobee, carrying around our big blue tentacles of Reach and serving as basically a stand-in for our future spacecraft. We needed power, propulsion, control, and sensing, and all of those factors. And Astrobee carries all of that we needed, and we were able to just drop our capture payload into there and be able to demonstrate it. And then up in the top middle, you can also see Honey, the yellow Astrobee up there, which was serving as a second camera, as Kirk was just showing as well, giving us kind of an up-close view of the action right where it was happening. We can go to the next slide. And this one shows some of the other testing, again, with Sonny Williams here helping out, where we were able to also, because of the unique opportunity Astrobee provides, have crew involved in those demonstrations as well and be able to test other configurations we otherwise wouldn't be able to. So we were able to do some tumbling captures shown here. We were able to approach from different angles and different relative speeds. And having crew there involved with Astrobee is a huge benefit because where operating outside, maybe we would have been able to get one or maybe two demonstrations. We ended up with over 170 capture cycles through the course of the 6 sessions we got on ISS. So we can go to the next slide, and we'll run through the next few pretty quick, as it's a couple of glamour shots showing what we did, and I've already touched on most of the material there. So basically, having Astrobee on station really served as a platform for us to be able to prove out the technology and showcase the capabilities. Next slide. And These are, again, a couple more of the shots from the various sessions utilizing both Astrobees, Bumble for driving the tentacles, Honey for observing. And as you can see on the left, sometimes we also swapped in Honey as the controller instead, giving us that additional capability. And we can go on to the next. This is overall our timeline. So ISS and Astrobee certainly was a stepping stone for our technology development. But as Kirk and others have mentioned, the community amongst Astrobee is so incredibly supportive and collaborative that we're very excited as we continue to grow our technology beyond Astrobee. Very excited to continue engaging with the rest of the community, sharing what we've learned and moving forward from there. We can go to the next. Lastly, just appreciate the opportunity to be involved, Dave, and everyone at Arkisys. Very excited to see Astrobee continue to move forward, especially with Jonathan and the rest from the Astrobee team. Happy to continue to stay involved and happy to connect, and appreciate the invite to be here. Looking forward to the rest. Thanks all.
Thanks very much, Alex. Really appreciate it. We have a great affinity for Reach and Calmora, so this is wonderful. Last but not least, we're going to have a local group actually talk about another experiment that was up there. Interesting enough, roughly about the same time as the previous astronauts that were up there, so you may or may not see some of the similar crew members. So Jackson Hill is going to represent Clingers from USC. Thanks.
Hello, everybody. My name is Jackson, and I'm a PhD student here at the CERC, which is part of ISI, which is part of USC. So we're in the same building. And I wanted to talk to you guys today about Clingers, which has been referenced earlier in this presentation. We can talk more about. Some of you may have seen this before and are familiar. Others maybe not so much. So we'll talk about what Clingers is and how it's been used in Astrobee to test for science. So Clingers is the unit in the top right of the screen. It stands for Compliant, Low-Profile, Independent, Non-Protruding, Genderless, and Electronic Rendezvous System. So what that means is it's a standalone element that all in one. Oh yeah, this is a video, so you can click the play while I'm talking here. Perfect, and it's a little time lapse, so it's sped up a little bit. So what this is, it's a standalone element that can be attached to a system to provide a common docking system, and it is combined both with the docking mechanism here, which is genderless, so there's not a male and female option. It is a single unit that can be replicated and can be docked with any altogether. Yes, and here's some experiments down below. And so it's the docking system also combined with the sensing system. So on board Clingers, there are LED lights and sensors on board so they can co-locate and find each other. And the truly unique thing about Clingers, which is what we were testing for, is attempting to quantify and show how collaborative docking and RPO is more efficient than traditional methods. So traditionally, RPO is done where one object stays stationary and the other one comes in and does all the work to come in and dock. And our hypothesis was that if both units combine, collaborate, and communicate, the docking process can be done much more efficiently. So this is what our goal was to demonstrate. On the next slide, you can see as we migrated from our ground test beds here at the CERC over to Astrobee and their test beds. As I said, Clingers is an all-in-one unit, but we still do need propulsion, and this is where Astrobee came in. This is our test bed for testing our whole RPO docking sequence from the ground, moving up to 6 degrees of freedom up in space. So this is also a video, Yashi, you can play, showing our successful dock down in 3 degrees of freedom over with Astrobee. I didn't speed this up, maybe I should have. So Astrobee communicates with Clingers directly to take inputs from Clingers to command what exact movements should happen, what orientations should happen, so that they can come together, click, and dock together. We have multiple different modes we tested with, so we could compare against our collaborative mode, where both units were talking to each other with Astrobee to come together, versus more traditional methods where one Astrobee was stationary and the other Clingers came in and docked, so we could have a comparison. So we can go to the next slide here. So this is perhaps more technical, but I wanted to show this up here so that if you have questions, you can come talk to us afterwards, and it's at least shown here. But this is more demonstrating the full communication scheme between all 4 objects here. So both Clingers units see each other with the aforementioned sensors and LED lights, so they can calculate the pose with the P&D algorithm. And both units also communicate with each Astrobee so they can take in movement requests and location to communicate and actually come together. So there's a lot of different communication streams happening all at once here. You can go to the next slide. So all in all, we have a nice little video here of the final, or not the final, of the completion of our testing from ground and our test bed to the Ames test bed up to all of our missions on the ISS here. So you can see Sunny being very excited as as they come together. Yeah. Just like a bowling ball, right? You got yeah, precisely. Great. Okay, and then we can go to the next slide with our mission accomplishments summary. Yes. So altogether, we had 6 science missions with 4 software uploads beforehand, for a grand total of about 24 hours of crew time with 9 different crew members. So we got to know them real well. We had about 40 rendezvous flights with about 6 successful contacts, which you can see in the picture here and from the video in the prior slide, with 3 of these modes tested. So these modes were what I mentioned, testing against traditional methods versus our cooperative and collaborative method, to get about 150 gigabytes of data. And if you want to know more about the specific results, you can come talk to us and we can share paper information about how those went. But I wanted to provide a brief overview of how Astrobee has enabled us to conduct these experiments and really push the boundaries of what RPO can be done in the future. And I think that's all I got here.
Awesome. So for Alyssa and Jackson, Kirk, and Austin, thanks very much. There is no question that past experiences on a platform are the best way to sort of sell things moving forward. So we'll continue on. All right. The idea that you've seen what's happened in the past, Jonathan told you the plethora of tests that have already occurred. You've got some ideas sort of how it was used in the past. Now what we want to do is we want to sort of seed you with what you might be able to do moving forward. There is no question that from sort of a standpoint of what you can do with Astrobee, you could literally, the sky is the limit. With an asterisk, subject to NASA approval, right? I'm making sure that that's correct. You've already seen ideas of robotic grasping and gripping that you can use. What you haven't seen is the Naval Research Lab actually did an experiment where they tested out some AI algorithms, very, very short period of time, but nonetheless, that's possible. You've already seen the idea of RPO and docking applications that can be applied in space. And then, of course, we have a number of STEM applications that are utilizing Astrobee. So that's all sort of very, very cool that we have this capability here. Some additional ideas, again, that I'll leave this in the package so you guys can see it before. I don't think there's anything that's necessarily different, but again, we're trying to show that not only is this a wonderful platform for a STEM involvement or to engage, but it's also a serious platform to begin to demonstrate and test various elements of what's needed in the entire sort of RPO scenario. Some new potential ideas that, again, just to seed the audience, if you will. There's no question that utilizing the cameras on board, you might be able to make some connections on the ground through either augmented or virtual reality. So that one brings a rather interesting potential demonstrable capability you can bring. In-space assembly, as Jonathan talked about, there are a number of payloads that are already up there, and Arkisys is working with the groups that own the hardware to make an agreement as can we use them, obviously in a mutual arrangement. Clingers is one of those. So one of the ideas was, well, what if you take one of the clingers off that's not powered and you attach it to something else, and now you have an Astrobee that comes up with another clingers, and now you can demonstrate sort of cargo grasping and then moving around. So that's an idea. You've already seen from MIT, they actually gamified things. There's no question you can use Astrobee to create different types of space games. One of the other ideas is obviously astronaut augmentation. One of the things that needs to be done by the crew on board, specifically for maintenance, is to make sure, as an example, the hatches are all good. Fairly important inside the space station. So it's possible you could do that also with an Astrobee. talked about logistics and supplies. Jonathan already talked about, at least we have a perch arm that's up there that could be utilized as part of the Astrobee portfolio. Potentially QR code inventory management. And then just to sort of throw out something different, which actually has been done, is space archaeology that's actually done on the space station. There's a professor from Chapman University that's done an amazing job to actually have done some of this, published papers, and gotten an award for it. So it's real and it's all possible. Again, based upon something else that's there. Okay, so at this point, I'm going to hand it off to Yashvi to talk about, well, okay, this is all great, Dave, but how do we get on? And that's sort of the more important.
Hello. So yeah, I'll be going through the customer onboarding and services that we'll be offering for Astrobee. So to start, there is the ISS integration process. If you have hardware, obviously you have to get up there. Software, you also have to have that validated. So Astrobee is an ISS facility. What that means is that it's a research platform that is available for other users to kind of work with that. And Arkisys is in negotiations to become a commercial implementation partner, which means that we'll be able to actually support you in running those operations and be doing all those things ourselves and maintaining the hardware instead of NASA. And all users of Astrobee require a sponsor. This is specifically for crew time and for upmass if you're actually trying to get hardware up there. This can come from multiple different spots. This is the United States operating segment. There's 4 agencies that are part of that. NASA has roughly a 50% allocation to this, where the ISS National Laboratory, which supports commercial service providers, has part of that allocation. And then there's also the European Space Agency, the Canadian Space Agency, and then JAXA as well, which have their own allocation for crew time and for upmass. And so what this is useful for is to help you kind of actually work with someone. Perhaps if you're international, maybe you can work with ESA and you can tap into their allocated upmass and their crew time as well. So our initial customer onboarding process, it starts with just signing up. We've got our form that you can fill out when you go to the website. There's a spot that says ISS Embark, and it asks for very basic information on your payload. You know, are you software, hardware? For hardware, it asks a very basic mass, power, and I believe volume. And so it's just kind of your contact information and that information just so that we can get the process started. And the next part is to connect, which is setting up a meeting with me. And I'll tell with that call, we'll discuss your mission, and also we'll get you credentials to our user dashboard, which is going to be a place where you can upload different documents, you can access templates, you can access other resources that might help you with troubleshooting or even just developing your payload. And then the next stage is assessment. So our team was going to conduct an assessment of your flight request so that we can give you the details to create a mission schedule, find out what services are needed for you specifically, and also assess compatibility of the payload with Astrobee. And then the next phase we have is agreement. And so we have to create a master service agreement with us. So you have to create one with us as a customer. We also have to get approval from the ISS National Lab and Arkisys. So that's something that's part of this phase. In addition, you can get added as a user on the Astrobee PIA list. And so this is important because it helps you remain a fixture in the NASA system. And so if you're making updates, you can make those updates within there. And you have access to you can actually be part of the schedule for crew time. And you're listed as your own payload, and you can make safety updates and actually access all that information. And so that's incredibly important because we want to make sure that we're following all the processes set by NASA, and we want to make sure that everything is in order. And the last part is to actually get started. After all of these have been completed, you've signed the agreements, we can start working with you on actually doing all the verification and validation for you, and working on getting integrated with all the NASA safety requirements, starting ground testing, developing procedures, and et cetera. So this is a very long, big slide, but our current list of services that we're offering, like I mentioned, we'll have our web portal. We'll be using Confluence to make our own schedule and then give automated reminders to everyone just to make sure that everything is staying on schedule. And this is specifically for stuff like milestones, like your PDR, CDR, and just like documents you might have to submit and that sort of thing. And then also we'll be supporting safety reviews as required. Obviously, it's a much more intensive process for hardware than software. So that's definitely important, as well as the NASA onboarding processes. Like I mentioned, getting part of the PIA user list, and also just getting approval from ISS and Arkisys overall. And then these are more specific to just validation and verification, where we can start that process before you actually get to ground testing, just to make sure that everything is at a basic level functioning well. and then have actual ground testing with us to be able to test before actual flight. We also have a section of just developing the procedures. This helped us a lot in the past to be able to have a designated set of things, especially when if something, hopefully it doesn't, but if something goes wrong, you have contingencies, you have a defined process for not only the ground crew, but also the actual astronaut that's helping you out. And then we're still determining how many hours this will take, but it's going to be primarily mission dependent, but we'll have a minimum hours to be set, which I'll talk about in a second, for this dedicated air bearing testing at our one of 3 options of ground test facilities. And then the last part is data transfer. Like Jackson mentioned, there's 150 gigabytes of clearance data. So we're going to be storing that, finding a way to actually send that to you in a secure manner. And then the enhanced services, these are just some add-ons. Which we have the early analysis recommendations for both safety and also flight requirements. And this is will be AI integrated just because we want to be able to work efficiently. We'll have multiple payloads. We want to also have the ability to find things that maybe our team would not have caught. And so we'll be using that to just kind of for an efficiency purposes, but of course still reviewing everything by ourselves and of course adhering to all the NASA safety and flight requirements. And then, like I mentioned, there's going to be a minimum for the time for ground testing and also for operations. And so that can also be increased depending on your mission. And then we'll also be supporting the APK development and making sure that you have a proper interface for flight control, whether that's through us or through you. And then the last 2, we have market match recommendations, which is a separate platform that we're developing to actually match your payload and your business to other people if in case they're interested in working with the likes. And the last part is more of an umbrella term, which is engineering support services. So we're happy to discuss if there's anything else that's needed. We can figure out what might be needed for your mission specifically. And then this is just an overview of what I talked about, where we have a tiered pricing approach. This is dependent on what the payload type is at the moment. Right now, tier 1 is for software. Tier 2 is software with a hardware add-on. For example, if you wanted to use the perch arm or clingers or MRS, once those agreements are finalized, we can work with you on how you can actually use those if you wanted to use their processor or something of the same. And then tier 3 is for hardware payloads, which this requires upmass unless you are one of the previously mentioned payloads. So the differences between these is additional crew time, which is required because for hardware payloads, there's obviously some more setup involved. And so this helps us to get set up before the actual operations time starts, and then helps you actually get the full time that you need within that slot. And then tier 3 also includes hardware environmental testing, which of course you don't need for software payloads. The last part here is just opportunities to showcase. So a bit of a marketing side. We have customizable eyes. Jonathan talked about the touchscreen LED screen on the face of the Astrobee. So those can be changed to have your own logo. This is just a mock-up with the Arkisys one. We also have a customizable skin. And so these are basically like a fabric attached and Velcroed onto the side. And so we can make custom ones. And we're working to find out how we can actually support upmass to potentially have those sent as well for not only hardware payloads, but potentially software ones as well. So that is a work in progress, but that is hopefully an option for us, and we'll be able to help with all the approvals required for the upmass part of it and also the branding and logo approvals. And then the last part is we have some folks in Building 8 of Johnson that support our photos and videos for live camera and also just the astronauts taking photos or any kind of other imagery that's happening. So with that approval, we can also send, high quality images and videos like all the PIs previously showed. There's obviously very, very nice cameras up there. They take really cool photos. So just to use that for also promotional purposes. And if you have any ideas, we're happy to bring them to life. We were thinking about doing things like with games, with other companies, other marketing approaches. So the door is very open for those opportunities as well, right?
Okay, so real quick, to sort of close it out, I want to be able to answer questions. So what's our current timeline? We're here today, October 13th. We have another presentation, a more detailed presentation next week at the ISS Payload Operators Integrated Working Group meeting, or POIG, in Huntsville, Alabama. We are seeking, right now, most people I don't think know that the Astrobees themselves, as Jonathan talked about, there's docks up there that they typically sit on. They were taken off the docks and put into stowage. We are going through the process. Again, as Yashvi talked about, of becoming an implementation partner with Cases, and as a part of that, we would then formally request for an activity to occur to take them out of the stowage, put them back on the docks. So the plan is to actually do that early December, if we can get through the government activities, get them powered up. We are looking at doing a first light test potentially in December as well. This would be very, very pared down. This would be just for sort of ourselves and our team to make sure all the connectivity is connected through the various communication links that are required, make sure the ground data systems are set up correctly, make sure that everything is connected through NASA before we then planning opening us up to our full user operations in January of next year. We're also planning to have some sort of software hackathon. We're still sort of working it. Honestly, got the inspiration from Zero Robotics. MIT has done it. The other thing that I'm not sure everybody knows, there's also another STEM program called Kibo RPC that's out of Japan. They actually have 8 or 9 different countries that they support. They also have done a hackathon. So more than likely, we're going to try to coordinate with those two about what would be the right kind of thing for us to do. Really just another way to sort of generate interest as well as to get people involved. And then the expectation is that the first user operations will begin in January of next year. That's currently what we're shooting for. And then after that, we'll be moving forward. As Yashvi talked about, and I wanted to make sure to sort of reiterate it, we're proposing 3 tiers worth of sort of services to support. As of right now, we were approved for software only operations on the ISS, given the changes that have occurred within the overall NASA budget relative to UPMAS. The second tier service that we talked about, that's why we're talking to the hardware providers that currently have hardware for payloads on board ISS that fit to Astrobee, because that would be the next step that honestly, collaboration, exactly what Jonathan talked about, and Abruta utilized another company's hardware to be able to test that. And that would be the next step. And so in the February timeframe, we're actually thinking that would be the first time we would actually use onboard payloads from another group connected in potentially with a new user. So that's really sort of the timeline. For those of you that have been familiar with Astrobee activities in the past, there's always been technical interface meetings. Those typically have occurred every quarter. We anticipate that we'll have the very first technical interchange meeting in the March timeframe as well. So we're, again, getting restarted through the end of this calendar year, and then really starting in January of next year. So, right, what's next? Honestly, as Yashvi talked about, bombard her with emails. No, just kidding. Sign up for the website. If you can't get on the website, definitely send an email. We are interested in talking to you. The next presentation, again, will be public. We will put it out on the website on the 22nd, which will get into a bit more technical details. Today was just really wanted to give you an overview. There will be more information put out. There will also be, our plan is to have the initial pricing identified, the software and hardware payload opportunities that are specified, and maybe some of the documentation you need in order to actually get onto Astrobee. We have 2 other emails for those that are interested in the general activity for what Arkisys is doing, and those that would love to provide some funding to us. We're happy to talk to you. We also have left you, we're not going to go through this, but for those interested, when you see the document, there's a host of information, again, harkening back and giving an accolade to NASA and Ames and the entire team that have already been put out there. This is all publicly released information that folks can get access to. Our job is not to sort of redo all of this. Our job is to point to it, it exists, and then bring together what we think is the right next steps to do so that we can help you all get up there as quickly as possible. So that's sort of where we're at. What's our time, Yashvi? Sorry? 11:30. Okay. We're doing pretty good on time. So now is the time for questions and answers. Not sure if the webinar is set up for.
You can ask questions.
Not sure if anybody's looking at it. I can't see it while the big screen's up here, but we'll offer it out to anybody in the audience at this point in time. Sir, yeah.
I know you mentioned that you are still exploring pricing, but I'm curious to know whether, like,
an experiment? Is it like in the tens of thousands of dollars, hundreds of thousands of dollars? Like how much would someone expect to pay for something
Fair,
like that?
yeah, no, it's a fair price. I knew we were going to get asked the question. So the range at the moment is between 50K and 150K.
Software only.
That's either software or hardware that's on board, right? Getting hardware up there, as I indicated, that's going to be a bit more both difficult and expensive. So it's going to be on the pressure side. But yeah, we're trying to actually stay within what is currently the industry standard pricing, if you will, for things that go up and experiment inside the ISS. So we're trying to be there. But at the same time, part of the reason I haven't given you a specific number is that when Astrobee was shut down in June, we're really trying to get our hands around all the bits and pieces to make sure that we truly understand what it takes to make Astrobee live. And so therefore, we actually think by next week, we're going to have a really good handle on it and hopefully we'll come up with the prices.
Nice. Thank you.
Yes? I believe it is. Is the POEG open?
I know you have to register for it.
Yeah, you have to register. I think if you go online, you can see it. But I believe it is. Yeah. Yeah, I believe it is.
We have a question online.
Yes.
Will you be able to have access to other agencies hosting facilities or only NASA ones?
For ground facilities specifically. So that's an interesting one. Let me answer the question first in terms of the ground facilities. So you saw on the chart, we had 3 options. The first option, which is an agreement that Arkisys is making with NASA Ames, is to utilize the existing granite table or air-bearing facility, which is up at NASA Ames. So the plan is to do that for a short period of time to transition. The second one is, again, a tease if you guys want to see activities tomorrow on the tour, is here at USC. There's going to be at least 1, if not 2 facilities that we might be able to also utilize here in the LA area. And then the long term, our plan is to have a very large facility that we can do sort of full scale operations. In terms of other NASA utilization of facilities, we do have access via the agreements that we have. As an example, if we need to have EMI testing, for example, if you want to put something up, acoustic testing, other types of testing that NASA facilities, they do have those. We would have to work out either directly an agreement on how do we use those if we have to pay for them, or you all might be able to use those. So I'm hoping that answers the question sort of encompassing. Yeah.
Interesting. Yeah, thank you. And do you have any collaboration with private companies like VAST or Starlab that are going to send private space stations, or SpaceX or Origin?
Yeah, no, that's a good question. So we've just started first to get our hands around operating Astrobee. We plan to reach out to them to see if there is interest in potentially testing something that might then be translated to it. We currently, as of right now, Astrobee it was designed for the ISS specifically. So all the communication links that occur to it, how to make connections to it, are specific to the ISS. It is uncertain, as an example, if you could actually take it and put it into a VAST module or an Axia module. But we actually did meet, Yashvi and I were in Johnson Space Center a couple of weeks ago. We actually did meet with the Voyager team. So the cool thing is that there's a lot of collaboration between the companies that are doing experiments and work on board the space station. Voyager is obviously one of those. Axiom is doing work up there as well. We are going to reach out to specifically those companies that are actually sending separate crew up or sending separate vehicles up to the ISS as a part of their activity. Again, going through the ISS National Lab relative to allotments for potential mass, if we want to try to get a piece of hardware. So I'm not sure if that answers your question. Our goal is to actually reach out or at least provide Astrobee availability to anybody who wants to test, and potentially reach out to these other companies that have future space stations if they see value in doing some testing with us, or more importantly, if there's another company that wants to potentially test and demonstrate something on Astrobee to showcase, hey, look, we have something that could be a free flight platform we're showing how it could be done, and then we want to offer that off to those in the future. Sir? Yeah.
Presentations, fascinating. Curious.
Jonathan, do you remember any input from past activities? I know that there have been some.
So I believe that the Astrosee experiment was a great example of non-cooperative. There was not, the estimation they were doing was all one, estimating the location of the other without the benefit of cooperation and knowledge from that. There have been a few other experiments that have done for the state estimation. Rome, which was put up there briefly, was one of those. So are you specifically asking about estimation or rendezvous docking?
Both.
So I think those ones would be the ones for state estimation. KMI did a great presentation on their non-cooperative docking and grappling.
So
I think you've seen most of the experiments at one point or another during this presentation.
Yeah, I'd actually recommend looking up. I think Keenan, you had write-ups on Rome because that was specifically attempting to identify rotation and nutation, then match it. So that was an experiment that was actually done with Astrobee. It wasn't Astrobee. This was even before Astrobee. There was another test that was done utilizing Astrobee. Yeah.
Partnership with the German species.
I have a question. When you mentioned on vision, you talked about still not view. Second question.
I cannot answer the radiation hardened question. I know it was a Jetson. I couldn't even tell you the model number. So that's the advantage of having this collaborative. There was a team, I'll give a little plug for MRS, was an Australian team, and they wanted to do some binocular vision algorithms and do internal mapping of the ISS. That was kind of what they wanted to do. And so they created a hardware payload. They needed extra power and extra space for a bigger baseline for their cameras. So they used the two Astrobee payload bays. It's actually, I don't know if you noticed, but it was double wide. So a standard Astrobee payload is about half that size, but they did double size to get better power and the wider, the more space. So they went through the process. They got their cameras up there. They used their hardware, and they were basically done with it when they were presenting some of their results. And this idea came up of, hey, they presented during this Astrobee TIM, the technical interface meeting, that what was in their hardware, what they'd used, just kind of their user experience. And the Abruta team picked up on that and said, hey, you've got a Jetson. And so that started the collaboration there, and they worked out that deal, and then they were able to utilize that hardware. So it's a separate piece that attaches to Astrobee. It's got mechanical attachments, power and data that flow between the Astrobee and the unit. So basically, the vision, Kirk can correct me if I'm wrong. Hopefully he's still on. But the camera would take the images and then ship it to the Jetson on the external module for processing, and then return the results. Yes. It's not. That's not to say you couldn't use the MRS cameras. In fact, we were making an attempt to try another thing out with their cameras, for a different use case. again, in that spirit of collaboration?
It's a good question, and we're trying to work hard with those that have this equipment on board to allow for this sort of cross collaboration to work, provide experiences for users. Yeah.
Can Astrobee host international European payloads?
Absolutely, yes. Again, Yashvi talked about the construct of a sponsor and the USOS, which is adjudicated by the ISS International Laboratory, ESA is part of that. So a sponsor, a payload within Europe theoretically would be able to go through ESA as a sponsor and then be able to be either put up or supported on Astrobee. So yes, absolutely.
Jeff Bezos said, I think 1 week ago, that in 10 years we will have huge data centers in space. And don't you think about this priority kind of, because it's a huge market also to operate in? Don't you think to going forward this market?
So that's, yeah, I'd love for us to step into the data center market in space, but relative to Astrobee, not quite sure I see an immediate step, except potentially what is going to make a data center in space. It's not just going to all be launched itself. More than likely, it's going to be assembled. There's a number of companies that are actually started up that want to do that. So the idea of, again, what are the fundamental functions required? Rendezvous, dock, assemble. All of those things potentially could be demonstrated at a subscale, at a microcosm level on Astrobee. But in terms of sort of hosting gigabytes or petabytes worth of data, I'm not quite sure that's what we'll do. Not quite sure Astrobee is ready for that. So it's a good point. Absolutely good point.
Thank you.
So you mentioned pricing, but integrate more closely with the existing NASA Flight Opportunities program, such that like companies who are pursuing diluted funding could have a sort of more direct path to working on Astrobee and setting up payloads?
Yeah, no, that's a good point. The group that we will go through is Cases, and Cases is the one that anybody can actually apply to. Cases typically puts out, as far as I know, they typically put out calls for experiments over periods of time. I'm not sure if they have one open right now or not, but that's one way to potentially do it. In terms of the Flight Opportunities Program, that's an interesting one because they offer suborbital and orbital flight potentials. I'm not quite sure. It's uncertain. We would have to work through the Cases folks to find out if somebody like yourself went to them and you say, hey, I want to point to some element of testing on Astrobee. How does that work? So I'm not quite sure.
Like in terms of sending up hardware payload.
Yeah. At the moment, anything that goes into the ISS goes through Cases in the ISS National Lab. So they were the ones that have to approve and or sponsor and or support in order to make that happen. So it's actually a good, we'll ask the question, hey, what if a company comes in from the outside and wants to test through the current flight programs? So that's a good question. Yeah. Any others online? No. Okay. All right. I know we're at, I think we're about at time, so I think we'll step through. Always want to leave with something sort of inspiring and interesting and different. So just sort of wanted to give you the idea of, creativity relative to DaVinci as to what Astrobee is doing, reaching out to our future architecture for the port module. So really appreciate everybody participating. It is truly an honor for us to be here today. Again, a big thank you and a shout out to the NASA community, specifically NASA Ames, who actually pulled all this together to make it happen. A nod to the Obi-Wan who started all of this through the Spears activity, and for all of you for coming out, both here in person as well as on the Zoom, who are online now or who may watch this in the future. Please get a hold of us. We're super excited about this. We're gonna make this thing go and make it even wonderful, more wonderful as we go forward. Again, we got big shoes to fill, but we're confident we can do it, and NASA really wants to see Astrobee fly. So thanks very much, everybody. Really appreciate it.
We can stick around for another 15 minutes and then we're going to be clearing the room. But please, if you'd like to come and say hi to Dave, stick around and say hi.